Hello everyone, welcome to Ekeeda platform, and this is Ravin Jangid here, your electrical faculty, and in this video I am going to talk about the numerical number 5, which is miscellaneous. So let's talk about one by one what are the different datas are given for this numerical. So we will start with the reading of this numerical. It is saying that the three-phase system having the 430 kV, so it is having the 430 kilovolt values and the 150 megawatt values, 150 in the sense 150 into 10 raised to power 6 values, is now it is converted. That is the three-phase AC system. That is three-phase AC system. Now it is converted into bipolar DC line. So AC system to DC system is converted, and what are the values are given? The 430 kilovolt and the 150 megawatt values are given assigned here. It is saying, okay, if you have converted into the bipolar DC line, then estimate what will be the DC voltage per pole and the DC line losses if the resistance values are given 0.05 and the power factor is 0.866. So let's start with the solution. We have already discussed this kind of numerical, but again we can go for it. Insulation strength is going to be the same because the same conductors are going to be converted from AC to DC transmission, whatever, but that doesn't matter. The insulation is going to be the same here. Now if we talk about the DC voltage of per pole, that is represented by the VD, and it is going to be root 2 upon 3. That is not root 2 upon 3, that is a 430 kilovolt value, and into root 2 by 3 maximum, and the also the phase value. That's why we have defined here. It is given the line voltage, we have to divide as we have to find the phase value, so we have divided by the root 3 and multiplied by root 2. Why? Because we need the peak value for that. So after calculation we are going to get the 351 kilovolt values. Now accordingly we will have the AC current per phase, and that AC current per phase we will have the 1000 into 1000, actually that is 150 into 10 raised to power 6. I have written in this way, that is nothing matter. Now root 3, 430 10 raised to power 3, 0.866, that is the power factor value. Now it is going to be 0.232 kilo ampere, or otherwise you can write 232 point something the values in the ampere. Now that will be converted into DC power, as the power will be going to be the same, and that is the 150 into 10 raised to power 6 values, that is the 150 megawatt. And as we have the formula, that is the 2 into ID into VD. What is the value of the ID is going to be? ID is 150 into 10 raised to power 6 and divided by 2 into 351 into 10 raised to power 3. That 351 is the voltage value, that is the VD, and we have found the here we have to find the ID value. So when we will calculate, then so how we will calculate? Cancel the 10 raised to power 3 to 10 raised to power 6 and use the calci. 150 divided by 2, it is going to be 75. Then again divided by 351 and multiplied by the 10 raised to power 3. So this is going to be 213.67 ampere. Now we will go for the DC line losses. This is the 2 ID square R. We are very much aware of this. The 2 ID R square. We generally use the ID square R, but here the bipolar lines are actually used, so we have multiplied by the 2. So after calculation, 2 into 213.67 whole power to 0.05, that is the value of the resistance. Then we are going to get 4.5 kilowatt, that is the DC line loss. I hope you have understood this numerical, this concept. Thank you so much.